Hey students, I wanted to give you a quick video showing the relationship between regular expressions and these weird diagrams that are called finite state automata. The two are linked, and once you trace it, you see, oh, that's how it works. What actually happens when we give a program a regular expression to generate a regular expression from and return some kind of an object that we can use. The processor actually is creating this finite state automata that is going to then be able to be traced through with candidate patterns to see if they match or not. So here's just exactly how that happens and how it goes about. First, let me change the pen color here to a blue, and that'll kind of show the tracing that we do. So first, let's take a look at this one here. This regular expression is C A asterisk B. So that means it needs a C, and then it needs 0 or more letter A's, and then it needs a B. So a finite state automata will always start with a state, a beginning state, and it'll end with an end state. And we say that after tracing all of this, if the pattern, the target pattern has completed processing, and if we're in this end state in the automata, then we say that it's a match. So how does this work? Well, to go from one node to the other, we simply exercise an expression. So in this case, to go from 1 to 2, we ensure that there is a lowercase c there. If that is the case, well, then we go to state 2, which tells us, all right, we need 0 or more letter A's. So if we had a candidate string like CAAB, we can really just sit here and knock these off. We successfully processed the C. If we wanted to process the first A, well, we take this route up and back and over itself. Then we go back to state 2 again. If we do this one, we do that again and we come back to state 2. And then a B means we move from state 2 over here to state 3. And this string now is fully done. And we have landed in this end state. So that means that this particular string passed the validation. It was a pattern match. Well, we'll run that also here on this next string, and our candidate will be, let's see, we'll do a C, A, B again, and then let's do another one with a C, C, A, B, B, and see how that sits. All right, now for this next one, let's look at that. And we're replacing the asterisk simply with the plus sign, which is the 1 or more operator. So this is going to require at least one A in the middle, and then we can have as many as we want before reaching the end state. So let's process this. We'll start here at the very beginning. Here is a C that we'll process and go over to here. Then our next character is in fact an A, and that lets us go from here to here because the only way to go there is with an A. Then we have another A, so let's process that, and the only way to do that is to loop back on itself, and that is the loop for A. And then finally a B, which gives us this loop here, and we traverse that edge there, and we go then to state 4, which is the end state. And we would call it a match again because now we are done processing the string and we're in the end state. Well, let's look with a different color about this string right here, C, C, A, B, B. Okay, well, we first start here in the first state. We see a C there, and there is a way to progress from node 1 to node 2 here, and that's with a C, so we do that. So now we're in node 2. Our next is another C. So we look, okay, are there any edges out of this or any paths to the next, or even a preceding, or any node that allows us to use a C? And there is not. So processing ends. We end here on node 2, which is not node 4. And then in this case, that string matching fails. Right, here's another example that's going to use the OR operator and parentheses for grouping. So this finite state machine is going to demand either the characters AX or the characters BY. So let's see if we've got this candidate string successful or not. We'll start here, and our first character is an A. Is there a path out of one that is an A? Yes, there is. So we will traverse that, and now we're in state 2, and we've processed that. Is there a way out of state 2 that uses an X? And yes, there is. It's this path right here. So now we'll go to state 4, and we'll process this. And lo and behold, we have finished processing this string, and we are in state 4, so we can conclusively say that that is a match. Here's a couple of others that we can take a look at. Let's look at this first one in this new list here that we'll process. A, and then either X or Y, and then B. So let's trace this now. The way we would code in a finite state machine, the X or Y is just simply with this construct right here. From node 2 to node 3, we can either go X or Y. It's that simple. So let's process this candidate string now. We've got an A, so that takes us from 1 to 2. Then we've got a Y, and there is a way to go from 2 to 3 or from 2 to anywhere else by using a Y, and that's this right here. So we will proceed over here to 3. Finally, we have a B. There's a way to proceed. We go to 4, and that is a match. Let's look at this other string right here, A, X, Y, B, and see if that matches or fails. All right, so we started state 1, and we can go to state 2 with an A. So there's that. We can go this way to state 3 with an X. So let's do that. And then is there any way from state 3 anywhere that gives us a Y? And there's not, because these are unidirectional. And they certainly can be bidirectional, but the way that we've got them are unidirectional. And there's no way out of state 3 except through a B. So this ends, and we're ending up here in state 3, which is not the end state. So this one clearly is going to fail for us. All right, here's another example. This one is going to accept any alphanumeric character and any number of them, including 0, and then the word the, followed by any other alphanumeric character. Okay, so let's look at the string before the time. Let's see if that's going to work. Okay, we'll start in state 1. We process this B. Is there a way out of state 1? And there is. That \W is any alphanumeric character. So this, we started state 1, I should say, and we will stay in state 1 after that B is processed. We'll stay in state 1 after the 4 is processed, because we're just going to keep going around this loop. Then we see, all right, is there a T? And there is. There is a T right here. This sort of splits off because T is also part of W. So this would give us kind of 2 states at once, a 1 or a 2. And is there an H? Yes, there is, from going from 2 to 3. So this lands us up at 3 after that. And then E lands us up in 4, and we stay in 4 then the whole time with any other characters going around this loop here. Now, if we remember from our reading and from the video, that with this regular expression, the question mark mandates 0 or 1 instances, and that's it. 0 or 1 instances. So let's see how that would work with this string right here, just simply with AC. First, to code a 0 or 1, the 0 part is we would just fast forward away from it. The one part is that we code that branch and then deal with the aftermath. So here we start at node 1. We process an A and we get to node 2. Is there a way out of node 2 or state 2 that is a C? And yes, there is. It takes us to 4. And then we're done here and we're done here. And that then is how that string would pass. All right, so I hope these help. We're not going to be doing these, but it is good to have good familiarity with finite state machines. And it's good to have a little experience just seeing how they relate to regular expressions. And this could be a whole course for an entire semester in and of itself with these finite state automata. Okay, thanks everybody.